Okay, let's do another word problem. It says a balloon rises vertically from point P on level ground. From point A on level ground, 28 feet from point P, the angle of elevation to the balloon is 79 degrees. How high is the balloon? Okay, so the first thing you want to do is says the balloon rises vertically from point P. So let's just have a point P. It says the balloon rises vertically from point P on level ground. So vertically. So that's going to be above you, right? So the balloon rises vertically. Now on level ground, 28 feet from point P. So level ground. So let's do 28 feet. So that's going to be point A, right? The angle of elevation to the balloon is 79 degrees. So the angle of elevation, if you remember, angle of elevation is going to go up, right? Otherwise, if it was this way, it'd be angle of depression. So we're going to do an angle of elevation. So if you just picture that, it says you're at 79 degrees. So this is going to be 90. Let's say it's something like this. So this angle here is telling us is 79 degrees. Okay, so now let's see what we have. We have an angle and one side. Since this is going vertically, we know this is a 90-degree angle. Okay, so we have two angles and a side. So what we can do, and we're looking, of course, is saying how high is the balloon. We're looking for the height of this. So we can call this B. So then what we can do is we can think about our SOHCAHTOA. And let's think about this triangle, what we have here. So we know if this is a 90-degree angle, across from that is going to be your hypotenuse. This is our angle. So opposite angle is over here. And then this is going to be adjacent. Okay, so we have our adjacent. We're looking for our opposite. So let's look at our SOHCAHTOA and see what we can use. So it looks like adjacent and opposite right here. We can use tangent. So we have tangent of 79 degrees equals, so tangent is opposite. Opposite we don't know, so we'll call that x. So we'll have opposite over adjacent, which is 28 feet. So now what we want to do is get x alone by itself. So we're going to times both by 28, which would leave us with 28 tangent of 79 degrees equals x. And now we're going to need a calculator for this next part. So you want to make sure you're in degrees. So we're going to have 79 degrees of tangent, and then you times that by 28. So it's saying it's 144.0475. So let's round up to the nearest hundredth. So you can have x equals 144.05 feet. So your height, the balloon is 144.05 feet high. And that is your final answer. Next question. It says a wheel has a radius of 20 centimeters. If it rolls 60 centimeters without slipping, through how many radians has it turned? First thing you want to do when you have this type of question is start drawing it, try to visualize it. So let's do, it says a wheel, right? So let's say this is a wheel, has a radius of 20, so we know a radius 20 centimeters. Also says if it rolls 60 centimeters without slipping, okay? So that's your starting point. It says if it rolls 60 centimeters. So let's say it's rolled up to here. So this would be 60 centimeters. So now it's a little easier to see. It says a wheel has a radius of 20 centimeters. If it rolls 60 centimeters without slipping, how many radians has it turned? So the first thing that we should try to figure out is this an area problem or an arc length problem? So the way to think about this is, think about like sewing thread. So you know how sewing thread is wrapped around something circular? So pretend this is the sewing thread here. So if it's wound up, you take a piece of the thread and you start rolling it, right? This will roll and you're going to get some thread as you start pulling it out. And that's what they're saying. You basically, so if you have thread around here and if you rolled it out 60 centimeters, then how many radians? So how much has this turned? How much has this roll of thread turned, right? So this yarn that's rolled out, you could basically roll it back on, right? If you wanted to, you could roll it back on. So this actually becomes your arc length. So this would be your length wrapped around the circle. That's the way you want to think about this problem. So then the formula for arc length is S equals R theta. So if we have our arc length, so this is our arc length. This is our radius, which is given to us. And this is going to be our unknown in this problem. Now that you know what you're looking for theta, you just plug in your given information. So if you have your arc length is 60, you know your radius is 20, and you don't know your theta, right? So now what we have to do is try to get theta alone by itself. So we're just gonna divide both sides by 20. This crosses down, 20 goes into 60 3 times. So now your theta equals 3. So your final answer, since it's asking through how many radians has it turned, you know that your theta equals 3 radians.